Welcome back. Today, we're doing an explainer on a really incredible piece of analysis by tech writer Aaron Rose. We're going to be looking at the Raspberry Pi. You probably remember it as this simple kind of geeky hobbyist tool, right? Well, over the last 14 years, it has quietly undergone an absolutely massive transformation. By mid-2026, this humble little green board has evolved into a fully mature global computing platform. It is literally powering everything from massive factory floors right down to the automation in our living rooms. Okay, let's dive into this. Think back to the original 2012 vision. Back then, it was just this tiny, super inexpensive computer, mostly designed to, rekindle an interest in programming for kids. Honestly, it was mostly seen as a fun toy for making LEDs blink. But flash forward to the 2026 reality, it's a full-blown global infrastructure platform. The contrast between these two eras, where it started and where it is now, is absolutely staggering. Aaron Rose actually uses a really brilliant concept to describe this evolution. He calls it a post-scarcity computing substrate. Now, what does that mean? Basically, it's a stable, ubiquitous platform that is still cheap enough that you can easily tinker and experiment with it, but, and this is the kicker, it's powerful enough to handle actual heavy-duty production workloads. The Pi sits at this incredibly rare intersection. It scaled up massively, but it completely managed to keep its unique identity intact. Section 1. Capable hardware and software. Right, so looking at the Raspberry Pi 5 and the Compute Module 4 and 5 family, the current hardware has officially pushed the Pi into territory that used to just belong to low-end desktop PCs. We're talking quad-core, 64-bit CPUs, dedicated PCIe lanes, native NVMe boot support, and some seriously beefy GPU improvements. And the best part? The engineers didn't just chase those high-end vanity metrics. They went after absolute capability and rock-solid reliability. It doesn't just look good on paper, it's just capable. Full stop. And what's really interesting about this is how these raw specs actually translate into legitimate heavy-duty applications in the real world. We are way past the days of just novelty weekend projects. The Pi is now heavily relied upon for edge computing, complex home automation systems, heavy industrial control on factory floors, and yeah, even running AI inference right at the edge. But while everyone was looking at the hardware, the software ecosystem quietly exploded. Raspberry Pi OS is now this incredibly polished, Debian-based environment. It's got first-class support for containers, orchestration, and those lightweight AI workloads we just mentioned. Plus, with the Pi Foundation's absolute commitment to long-term support, developers know for sure they can deploy a system today and literally rely on it for years to come without it breaking. Section 2. The local first shift. Now, you might be wondering, why does this matter to us right now? Well, with cloud subscription costs constantly creeping up, and let's be honest, privacy concerns mounting every single day, the whole way we view personal computing is totally changing. The Pi has effectively become the go-to platform for data sovereignty. People are using it to run these incredibly frictionless applications, things like home media servers, offline personal AI assistants, self-hosted dashboards, and complex automation rules engines. It is the hardware you reach for when you want absolute, total control over your own data. Section 3. The rise of Pi clusters. So, the crucial point here is this specific number, 4 to 8. What used to be this quirky novelty, like, hey, look at me, I built a tiny little supercomputer, has become a seriously practical tool. It's now actually incredibly common to see a 4 to 8 node Pi cluster quietly running a modern household's entire digital life. And it does it all with ridiculously low power draw and barely any noise. And these aren't just sitting there collecting dust. These tiny supercomputers are processing serious day-to-day workloads. They're handling distributed computing tasks, they're running developers' CI and CD pipelines, managing edge Kubernetes deployments, hosting AI models, and acting as redundant home servers. They have completely 100% shed that old novelty status. Section 4. Retaining its maker roots. Now, despite all this new industrial muscle, the platform hasn't lost its soul. The famous GPIO pins remain an absolute cultural icon. This brilliantly illustrates how the Pi acts as a physical reminder that computing doesn't have to be some closed-off, mysterious black box. It can be tactile, it can be playful, and totally expressive. It really remains the absolute easiest way to teach kids what a computer truly is, rather than just teaching them how to swipe on a piece of glass. And the maker ecosystem? It's stronger than ever. It's fueled by this massive library of open source projects, incredibly affordable sensors, and those add-on boards they call hats. Plus, there is a global community that thoroughly documents literally everything, and you see widespread adoption in classrooms everywhere. All of this ensures that the pipeline of new, curious creators just keeps flowing worldwide. When you put all of this together, it builds into this wonderfully, defiantly practical niche for the pie. Think about it. In a world completely saturated with disposable devices and endless subscription software, the advantages are so clear. It's way cheaper than a laptop, it's vastly more flexible than renting a cloud virtual machine, it's significantly more durable than your standard consumer hardware, and its ecosystem is more open than nearly anything else in its entire class. I really want to highlight this profound quote from Aaron Rose's article because it completely flips that standard Silicon Valley mantra of move fast and break things right on its head. He writes, "Progress doesn't always require disruption. Sometimes the winning move is consistency, slow, steady refinement, and a commitment to serving real people doing real work." That idea, that slow, steady refinement, can turn a humble educational tool into a piece of global infrastructure is just incredible to think about. And it leaves us with a really powerful final thought for this explainer. How could frugal, human-centered technology reshape your own digital life? Whether it's finally taking back your data or just building something fun in the garage on a weekend, the tools are right there waiting for you. Thanks so much for joining me today. Keep exploring, and I'll catch you in the next one.